Okay, here we are with another exponent property or exponent rule. This is what we call quotient with the same base. Okay, by the title you can presume that we are dealing with division. So let's say you have number a that's raised to the nth power, and we are dividing it by the same number but raised to a different exponent. How we simplify something like this, we can rewrite it as a raised to the power of, you're going to subtract your exponents here. So you're going to take your numerator's exponent and then subtract your denominator's exponent. Just like that. So you can rewrite them just like that. Let's take a look at a numerical example here. Let's go with 2 to the 5th power divided by 2 to the 3rd power. Now, following my rule, right, I can rewrite this with my base. So notice my bases are the same. So I can rewrite it there. And then I'm just subtracting the numerator's exponent and the denominators. So my answer simplifies to 2 squared, which we know is equal to 4. Okay, let's take a look at another example. Let's go with red. Okay, let's say I have a negative exponent in here. Let's do that. We'll do 2 to the negative 3rd power divided by 2 to the 2nd power. Now, notice how my bases are the same. So that means I can use this rule here. So I keep it there, and I subtract my two exponents. So my numerator minus the denominator's exponent, which we know negative 3 minus 2 is negative 5. So our answer so far is 2 to the negative 5th power. But as you know, we do not like negative numbers in our answer. So we need to simplify this. So following the rule for negative exponents, my answer is now 1 over 2 to the 5th power. And that simplifies to 1 over 32. And there you have it. Let's take a look at an example with variables. So remember that the bases are going to be the same. So let's do x to the 11th power divided by x to the 7th power. My bases are the same, so I can use this rule here. So I keep my base, and I subtract my exponents, 11 minus 7. And please make sure you're subtracting the order does matter here. So make sure you're subtracting the denominator from the numerator. Okay? So our answer simplifies to x to the 4th power. So I wanted to take a little bit of time talking about why we work with negative exponents the way we do. So take a look. So we know that this value here, 2 to the negative 3rd, is the same as 1 over 2 to the 3rd. Okay? So bear with me for a second. Now, I can rewrite this as a division problem like the ones we've been solving, like any of these, right? I just need to make sure that whatever I subtract, my value is equal to negative 3. So let's take a look. I'm going to rewrite 2 to the negative 3rd. I'm going to do 6. Yeah, let's do 2 to the 6th. Whoops. 2 to the 6th divided by 2 to the 9th power. Now, following my rule, because the bases are the same, I can rewrite this as 6 minus 9, which is the same as 2 to the negative third power. Okay, but how do we go from here to here? That is a great question. Let's take a look. If you think about what exponents are, if you think about what exponents are and what they're doing, right, they're just repeated multiplication over and over and over, right? So I'm going to rewrite this in expanded form. I know that this is 2 times 2. I should have used such large exponents, 3, 4, 5, 6, and that is written over 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, what's nice, when you have a number over itself as a fraction, you get 1, correct? So, all of these pairs of 2's become 1's. In other words, they're canceling each other out, right? So, these cancel each other out. 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 And these cancel each other's out. What is left in the numerator? Well, all of these are just 1's, right? Because they're all 2 over 2's. And 1 times 1 times 1 times 1 times 1 is just 1. What am I left with in the denominator? Well, I have these 3 2's, which I can rewrite as 2 to the third power. So we just proved that 2 to the negative third power is the same thing as 1 over 2 to the third power. So hopefully that kind of clarifies why we work with negative exponents the way we do. But let me know if you guys have any questions about that, because I know negative exponents can be a little tricky. All right. Well, there you have quotients with the same base.